All right, so here are some SAT questions. Another SAT section. This is the translate section, and this one is translating all about linear equations. So first off, before we even look at a question, let's think about what a linear equation is. So I would start with everyone's favorite thing about linear equations, y equals mx plus b. And so remember what this is. Your m is your slope, and your b is your y-intercept. But I want to think more about those besides just those specific vocab words. What does that actually mean? So the slope is, you say the rise over run. So it's talking about like how much it's increasing, right? Over some x. So that's like sort of over some time interval. So whenever I see slope, I always think about the slope is always a rate. It should always be like something per something. So think miles per hour, or think like meters per second. Think that's always a rate when it's the slope. And then the y-intercept, well, think for a second, how do you find the y-intercept? Well, it's when the x value is 0, and generally the x is like the time. So this here, I always think about what it is when the time is equal to 0. And what does that mean? The time is equal to 0. Well, that's like the beginning. So I always say that this is the starting amount. And then when you look at these linear equations like that makes things a lot more clearer. You always have your rate times x plus your starting amount. And then now that we understand that, let's see how that just directly applies to this. So let's read the question. One of the requirements for becoming a court reporter is the ability to type 225 words per minute. Donald can currently type 180 words per minute and believes that with practice he can increase his typing speed by 5 words per minute each month. Which of the following represents the number of words per minute Donald believes he will be able to type after M months? So just like we said, we've got our starting amount and we've got the rate. So the starting amount is 180. So that's the thing that needs to not be multiplied by the variable. So that means it has to be C or D. And then he can increase it by 5 words per minute each month. So 5, that's the rate. And it's increasing, so it's positive. So plus 5m. And so with all of these, we're going to keep that in mind. And that's going to be super useful, I think. Now, we don't always need to think about that exactly. But like, let's look at this. So 1 pound of grapes costs $2. At this rate, how many dollars will C pounds of grape cost? Well, I guess we could think about it like that. Because we saw with y equals mx plus b. And so what is the rate and what is the starting amount? Well, the rate is that $2 per pound. So we should have 2x. And then what's the starting amount? If we buy 0 grapes, how much will it cost? It'll cost $0. So that's like 2x plus 0. And so which of those is like 2x? 2c. And there we go. Now let's look at 25. So for 25, it says, if X food calories is equivalent to K kilojoules, which of the following best represents between X and K? So they're saying that these are the X, the food calories are the X, and this is the K. So we could try to calculate some rate and try to find the equation, but I think this is a good example of one where we can just plug into the answer choices they give us. We should take advantage of the fact that it's multiple choice. So we can say, just look at any of these values, like look at these right here, that if X is 4, K should be 16.7. And if you look down at those equations, notice that 16, that's like 4 times 4. So which of these equations is like taking X and multiplying it by 4 to get K? Well, that's definitely B. And you try to plug them into the other equations, and you'll see that they definitely do not work. Maybe this one, maybe A seems like it works. Oh, no, A does not seem like it works because that's an X. I thought they switched the X and the K. No, A definitely does not work. 0.2 times 4 definitely is not 16. So yeah, just notice a lot of times if they're giving you different equations and you know like these are points, right? 4 comma 16.7 that work for the equation, you can plug them in and see which one works. Now here you could do that too if you want, but I think there's better things to do. So the table above shows the population of Greenleaf, Idaho for the years 2000 to 2010. So first off, I think this question is hilarious. Just imagine if you're in Greenleaf, Idaho, like your town has 800 people in it and it gets called out in an SAT question. Like if you're from New York City or something like that, that happens all the time. But you're from Greenleaf, Idaho, population of 850, and your town gets called out in an SAT question. That's ridiculous. Anyway, so basically just trying to write the equation. And so I would think we have a starting amount and we have a rate. So they tell us that we're starting, it's T years after 2000. So we're starting in 2000. So what is the amount in 2000? 862. So our starting amount is 862. Now we look at these and they all have that. So that's not actually going to help us. So first off, I would say this is kind of curious with this T minus 2000. What is this T minus 2000 doing here? Well, it all depends on what T is. See how they tell us that it's T years after 2000. So that's like if it's 2010, T is the number of years after 2000. So T would be 10, because that's 10 years after the year 2000. And what's going on with C and D is like if they didn't say that. So like if they just said that T was like the year, then T would be 2010 in the year 2000. And if that was the case, in order to do all this math starting at the year 2000, you would have to subtract 2000 from it. So that's what's going on there. And so just kind of notice that if you know that T is 10 here because it's 10 years after 2000, it makes no sense to do 10 minus 2000 here. And so we're definitely going to cross out C and D because of that. And then now what choice do we have to make? We just have to choose between, is it 1.6 or is it 16 as our rate? And so remember, that's a rate. So you might look at this and you see, well, it is going down 16 in population over those 10 years, but it's exactly that. It's over those 10 years. So what is the rate actually? 1.6. A. And so that doesn't happen. I think that's the only question where they do some weird thing like this. But just know that that's what they're talking about. That's what would happen if T was just years. But usually T is years starting somewhere. All right, on to the next one. So, a photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it's used 30% of the paper. Which of the following models the equation? So I actually got this question wrong for a long time. But I see the problem now. A student actually had to correct me. Because I saw 30% of the paper, and that told me immediately, oh, exponential function. And so I'm like, use 30%, so that means there's 70% left. And then I chose that one. But that makes no sense. For one, why is a copy machine going to be exponential? A copy machine's not going to slow down or speed up over the time of it copying. It's just going to go at a consistent rate. And what is it? It even tells us that. It goes at a constant rate. And so if it goes at a constant rate, that's linear. That's like definition linear. So we need to cross out C and D right away because this is a linear equation. And then now we're choosing between these two. So we can do the math. But one strategy that I do like to point out that's useful is looking at the answers and thinking, like, where did they get these numbers? So 75 and 20. And I'm not exactly going to say what you think, because I'm not going to say look for the number that's in the equation. I'm actually going to say, like, notice that 20 is in the equation. But why on earth would you put that 20 there? That makes no sense to put that 20 there. So I think that's what they're trying to trick people who's just trying to compare numbers. And that would tell me that it's almost definitely not A, because that 20 has no business just going there. But that's where they got that answer from. So that would tell me it's probably B. But now why is it B? Well, how much paper are they using per minute? That's the question. And we have to calculate that. And we can calculate that because they're using 5,000 sheets of paper. Well, it starts with 5,000 sheets of paper. And they do tell us it uses 30% in 20 minutes. It's not using 30% every 20 minutes like it would be if it was exponential. It's just using 30% in 20 minutes. It's going to use the next 30% in the next 20 minutes, and so on. But so we can calculate how many pages it uses per minute by calculating 30% of 5,000 and then divide by 20. So what, 0.3 times 5,000? What is that? You do that, right? So it's like 3 times 5. So that's 1,500. So it does 1,500 pages in 20 minutes. Cancel out the zeros. It does 75 pages in 1 minute. And the reason it's minus is because that's going down, because your equation is for how many pages are in the machine. Next question. The front of a roller coaster car is at the bottom of the hill and is 15 feet above the ground. Okay. If the front of the roller coaster car rises at a constant rate at 8 feet per second, which of the following equations gives the height in feet per second? So look at that. That's just straightforward, exactly what we've said. We've got the rate and we've got the starting amount. They tell us the starting amount is 15. It's 15 feet above the ground. So that's all we need to know, right? Hey. Okay. Sometimes the SAT throws you soft ones like that. All right. A company purchased a machine valued at $120,000. Sounds like a starting amount. The value of the machine depreciates by the same amount each year, so that after 10 years, the value will be $30,000. Which of the following equations gives the value after that many years? So, like we said, it's going to start at $120,000. So let's cross that off. We got to think of the rate. So let me softly cross that off because, like we said before, that 30,000 has no business just going right there. And between B and C, well, the rate's going down. So if the rate's going down, we can definitely cross off C. So I like B. But again, where are they getting that 9,000 from? Well, that's because it's going down to 30,000. But what is the total going down? Well, it's going down 90,000, right? 120 to 30. But that's not the slope because it's doing that over 10 years. So that's where the 9,000 is coming from. But that's why I like multiple choice tests, because you don't actually have to get the answer all the way to get it. All right. This is an annoying question to me. So let's read what it says. If P% of adults' daily allowance of potassium is provided by X servings of crunchy grain, which of the following expresses P in terms of X? So they kind of trick you here with all just the percent nonsense. So, and I think I was confused maybe about this when I was younger too, about what that means on the back of cereal boxes and stuff. It's so like, look what it tells you here too. It tells you one serving, each serving gives you 5%. So how many does 2 servings get you? Well, it's just 10%, right? Like that's how they're calculating it, because it's just 5% of everything you need. So if you have 2 of them, that's 10% of everything you need. If you had 20 of them, that would be 100% of everything you need. So based on that, I'm already thinking that it's going to be like 5% times how many servings you have. But then when I hear that, I want to say like 0.05 times X. Because to me, percent is like 0.05. But notice they were very kind, I think, and didn't put that as an answer choice. Because we already know it's not exponential. And if that was an answer choice, I probably would have put that. But look at how they read this, or how they write this. It's P%. So it's like when P is 5, that's 5%. And that's what we're like trying to calculate, right? So that means that it's going to be B, because then it's like when we have 1 serving, P is 5, so it's 5%. If we have 2 servings, P is 10, so it's 10%. And so that's a really confusing kind of question. But that's also like an SAT. The thing with the SAT is the questions are confusing, that they're easy to do, but they can be confusing. All right. A television with a price of $300 is to be purchased with an initial payment of $60, starting amount, and weekly payments of $30 per week, the rate. Which of the following equations can be used to find the number of weekly payments required to make the complete purchase, assuming there's no taxes or fees? Or interest. I guess that's the fees. So notice we don't even have to decide. They all equal 300. That's because that's the total amount we're trying to calculate. And so we just got to do what we said. We said it's going to be initial payment of 60. That's our starting amount. And I mean, right there, this is the only one that has initial payment of positive 60. And then we see also the $30 per week. And it's going to be plus because we're adding together all the money that we're paying to get the money on the right side. There's no minus or anything. So yeah, there we go. All right, next. This one looks straightforward. So a helicopter initially hovering 40 feet, starting amount, above the ground begins to gain altitude at a rate of 21 feet per second. Rate. So we don't even need to do the rest of the question. It starts at 40, goes up by 21. B. Because you look at the answer choices too. The answer choices tell you what you're trying to do. It's that you're trying to write the equation for the situation. You don't need to read, because I think that's what people get confused. You read this question, which of the following functions represents the helicopter's altitude above the ground, y, in feet, t seconds after helicopter begins to gain altitude? Like, yeah, that's a wordy question to just say, write the equation for the situation. But you know you're just trying to write the equation of the situation because you look at the answer choices. All right, let's go to the next one. Same idea. So you're trying to write the equation because we look at the answer choices. So we have a starting amount and we have a rate. So I look at this and I think, how much is this going up by? So this goes up by 5. This is going from like 16 to 21 roughly. So that's going up like roughly 5. And you see how that continues. That goes up 10. That goes up roughly 10. So you look at that weight, like the slope, that's the rate, right, is about $1 per pound. So we know our rate should be about $1 per pound. So that shows that it's either got to be A or B. And then think about this, our starting amount. So in this case, how much it would cost if it weighed 0 pounds. And if we finish this pattern, it shows that it wouldn't be nothing, right? It wouldn't be nothing. I just wrote nothing. It would be 5 less because it's 5 pounds less. So that would be about 11 something. And you see how that's what we have right here. So why does it cost money to send 0 pounds? Well, that's just like the shipping charges. That's just like the box, how much it's going to cost no matter how much it weighs. And then they just charge you a little extra for how much it weighs. So that's another way to think about the starting amount is I'll say like the service charge or something. Or like if you buy tickets, you're going to pay a service charge and then plus however many tickets you buy, but you're paying the same amount for the service charge no matter how many tickets you buy. All right, next. The cost of using a telephone in a hotel meeting room is 20 cents per minute. Which of the following equation represents the total cost in dollars per hour? Okay, so first off, we've got to do a little dimensional analysis talking about units. I have a whole section called units that we'll talk about later, but this is pretty much the key of it, dimensional analysis. So they're telling us that it's 20 cents per minute. So we'll write $0.2 per minute. But then we want it to be talking about hours. So we want not 20 cents per minute, but we want like per hour. So how are we going to do that? We're going to cancel out the minutes. And so we want to multiply by a fraction that's equal to 1. So this is the idea that there's 60 minutes in 1 hour. So if we do 60 minutes divided by 1 hour, that's 1, because those are the same things. So we can also multiply by 1 and not change anything. But when we do that, we can cancel out these minutes. And now see if we do 0.2 times 60. Well, they actually don't even want us to do that. But 0.2 times $60 per hour. That's our rate. And so now what is our equation going to be? Well, we're going to multiply that by like our variable. So that's why I'm like an A. Because see how we have the 0.2 times 60. That's your rate. That's your slope. Times however many hours you use it. And you can calculate that to see how if hours is 1, then you're just doing 0.2 times 60 and you're getting the $1.20 per hour. Like we said, if it was 2, you just multiply that by 2, so it's $2.40 per hour. So that's just a little complicated looking because you got to convert it. But yeah, that's fine. And that is that section. So I think we're going to leave it there, and we'll come back and we'll do the next section is identify linear, which is basically just going the other way. They're going to give you the equation and you're going to say what each part means. So I'll see you next time for that one.